So what I want you to do, I want you to please go to your Canvas page, and what we're gonna do on at this time, we're gonna go through the basic tutorial 2, and in order to do that, I'm gonna also then release a dataset. It's a vehicle dataset. Please download it, and please make sure you unzip the folder. Otherwise, the MATLAB cannot go through it. We can write a code for that, but I'm looking actually to prevent any coding, so it will be more like a drag and drop. To download that one, load your MATLAB, which I assume you have 2025A. Yeah. I tried this with the multiple MATLAB packages to work, so I haven't tried that 5A, but it will hopefully work. Let's try this before as well. Download these, know where it is. If you want, you can move it to your desktop folder or keep it in the download, but just make sure you remember the location of it, because we're gonna go and use that location. Okay. Let me know when you're ready. Look at your data sets. See what type of images you have. You can see that there are images of the motorbikes, vehicles, bicycles. You have the image in different sizes. The number of images in each class is different. And then think about the discussion that we've had about the challenges of having the imbalanced data sets and so on, because this is something that you need to talk about in your presentation. And also, I would highly recommend to grab a notepad and start writing these things that I will talk about. I started recording. I'm not sure they will be fully recorded. If I record it, usually my computer crashed because we're going to do heavy simulations. But then I do have some pre-recorded materials on this, so we can go through it.
You know when people are trying to train models,
Yeah.
how do they go about getting organizations use
These data sets?
Yeah, and stuff like that.
So I will talk about it. There are different data sets available on the internet. Some of them are open source.
Yeah.
So there are some websites like Kaggle, for instance. They're basically open source images. You can work with them. Some of the data set actually then publicly is available and as a set benchmark. So if you're developing your own basic neural network, you have to test it with these to make sure actually is valid, which lots of images quite similar to capture codes that you'll see. And there's a dataset called ImageNet, million images, 1,000 categories. But lots of them are private. So those private ones, you will basically contact them. They will give you allowance. They need to find out whether you're going to use it commercially or going to use it locally.
Yeah.
For commercialization, most of these you will start with the public data sets, but then you have your own set of data sets. For example, car manufacturers. So what they're currently doing, the programming side of it now, NVIDIA is mainly take up, but each company will give their own data sets that they collect through the cameras on the car. And some of them actually, like famous, they go around and scan techniques. So it's really valuable, the data set, because it's big data. Some of those big data, the value of it is more than a company.
That's what people do, like data sets of like client lists and stuff. They sell that out. That's what they produce.
Absolutely, yes.
So, yeah.
So it's It's basically one of the assets these days.
Yeah.
But of course, there are AI tools that you can actually use that will go through and download the images from the internet, like Google and so on. But it's not recommended because you don't know whether the image has a copyright or not. Great. So let's begin. What we're going to do, we're going to use a tool called Deep Network Designer. The tool, I'm going to show it to you, but please don't load it. The tool, if you want to have a look at it, is in apps, and it's in the machine learning and deep learning package, and it's called Deep Network Designer. So this is basically another package of MATLAB, an expensive one, which now is basically become quite trending. Lots of companies started to use and so on. There is an issue with this one. So I didn't want you to load it, but it's okay. Can you please go to the blank one? So I'm going to show you something. So you will see you can only create network. It doesn't generate the code for you, doesn't do anything. So the tool that we're going to use, it was a tool that MATLAB launched it a couple of years ago, which quite interesting because you drag and drop these, you create your neural network, it writes the code for you. But they had to kill it because of the OpenAI collaboration, so they found it as a kind of competition, confusing for people and so on. So they started to get rid of that tool. But there's a way we can actually load it. So if you're using MATLAB 2023 A and B, it's already part of MATLAB. If you're using the 4B onwards, then you need to use this code. That's the code that we need to use. If you go to your canvas, I put the code for you. It's called Deep Network Designer. And it's the version 1 of it. And once we're going to enter these, which is the code that I put it on top of tutorial in here over here, this matter. Deep Network Designer V1. Actually, no. So you're going to bring the quite similar to what's basically you loaded, but then this one you can actually then design your network, you can load your images, it also writes code for you. And fine. Great. So did you get that as well? Was it interrogates? You can be semi-final back now. Yes. So in here, what we're gonna do, we're gonna start with the blank network, then I will talk about the rest of those networks which is available that you can use for your coursework. But let's start from the blank network. So this is quite similar to what we have actually done 2 weeks ago. I don't know how much of that actually you remember. The one actually we've done with the coding, right? I don't know whether you have your notes with you. We're gonna go through and create the exact same networks, but this time without coding. Right. So do you remember that kind of, the network architecture? We talked about the CNN. So do you remember what was the first layer? You will have an exam question on that. Right. So we'll have an input layer. The input layer, if you see on the left-hand side, we have the library. So click on a blank network. And on the left-hand side, you will see there's a layer, it's called image input layer. Click on that or drag and drop it into the page. Click on that block. It asks you for some values and input size. Do you remember what was the input size? There are 3 values over there. What they're standing for? So is it width, height of the image, and the depth of the image. And depth we say the color. If it's RGB, 3, CMYK is 4. If it's the black and white is 1. Yeah. Right. The depth and color. Depth. Height, width. So the beauty of this tool, if your images, you can see actually your data, each image had a different size. It's gonna force it in this size, and it's gonna be recommended. Usually 227 and 224. You don't have to. I can put 1000 by 2000. But bear in mind, if you have few hundred of images, that's gonna be the size of it. Mostly the computer will start crashing if you have a really big image. We try to reduce it. The activity you've done 2 weeks ago, the size of it was 20 by 20. It was really small. What we're going to do today, we're going to develop a system to see the objects in front of the car. 20 by 20 is really small for a car to be able to identify. So that's the recommended one, right? So if you want, you can change it. I'm happy with everything, so I'm going to keep it as it is. What was the next layer? In the CNN architecture. Convolution layer, right? So what we're gonna do, we're gonna use a convolution 2D. So we're gonna have a 2D image and we're gonna use a convolution 2D. So please click on the conv 2D and that's gonna be your second layer. Drag and drop it in here. And you will see some values. So the first one that we can change is called filter size. The filter size was a matrix. Remember that? We talked about it. So we use a 3 by 3 matrix, for instance. And under the filter size, we have the number of filters. Do you remember how many filters we use for our number classifications? So usually, what we do as a practice, we go with the 8, 16, 32, 64. We make the network deeper and deeper, right? So please change the number of filters from 32 to 8. And we're going to keep the padding as the same. We discussed about the padding. So padding, if you have a feature on the corner of the image, so we can increase the size, the border size of the image. So you will see, keep it as it is. And now what I want the input data to go to my convolution layer. So please connect the bottom of the input layer, the out of it, to the in of convolution layer. What was after convolution layer? Yes, and before that we had normalization, right? So we're going to normalize it and then we're going to downsample it. So it's called batch normalization. Batch normalization is going to be in your normalization category. And please drag and drop batch normalization layer and then connect that to your conv 2D. Great. After batch normalization layer, we're gonna do a basically set normalization, which is a ReLU layer. Again, ReLU layer is in activations, so please drag and drop the ReLU layer. You don't need to do anything with it. Just connect it back to the batch normalization. And then after that, as you mentioned, we're gonna have a max pooling. Because we use conv 2D, which is a 2D image, the max pooling of that will also be 2D. So please look for max pooling, which is going to be in the pooling category. I'm going to drag and drop max pooling to the layer, connect it to the ReLU layer, and select your max pooling block. In your max pooling, you remember actually we discussed about that's a downsampling, right? So if you click on the max pooling block, you will see it wants for 2 set of values. The pool size and a stripe. We want to downsample it by 2 times, and we're going to use a matrix of 2 by 2 to go around it. So any kind of non-important information, we're going to get rid of it because you will see that if you don't do it, the computers will struggle to come up with the proper results. So please change the pool size by 2 by 2 and a stride of it by 2 by 2. So we're going to downsample it by 2, and we're going to put a matrix of 2 by 2 to go around it. We said that the networks needs to get deeper and deeper. So the next one, I need to copy exactly what I've done. And now I will bring a more set of layers with 16 filters. I'm lazy. I don't want to do that. So what I can do, I can drag the mouse, select all of these basically 4 layers. I can either click on copy on the top, or I can do the Control C, Control V, and get another set of these layers. Connect them back from the max pool. And instead of the 8 number of filters in the conv2D, I'm going to change that to 16. So what you notice, the network gets deeper and deeper. That's why it's called deep learning. If you forget about why we are doing this or what each layer does, please have a look at the lectures. Please look at the basic first tutorial we've done on MATLAB. There's a guide on every single basically block of these. Great.
How do you connect the copy block? Same. Mine doesn't go to finish.
Not the input. You have one input, right?
It's just like at the end of that.
Yeah.
So it goes straight to the column. You have one.
Now we're going to do it one more time. So instead of 16, we're going to have 32 number of filters. So we're going to copy and paste the last basically 4 layers that we had. And this time we're going to have 32 layers. We can keep continuing these. If you have more of these, the network gets deeper, probably the network gets more accurate, but then you need more computer power and you need more time of processing. So it's quite similar to the approach you have in the machine, right? You need to find a balance, and that balance needs experience.
How did you say it was the assignment? Was it
140 layers, which I will explain. There's a trick you don't explain. For this part of it, as a scratch, probably I think you need to go with 7 layers.
So before we do the 144, we must do this for 12 times.
Yes, but then still your max you need to downstand layer loss. So can you check your notes at the end? Once we collected all of these basic layers, how we can put them back to each other? You remember those? So let's say you are learning in the module. Before we go to an exam, you're going to then bring all the information to technically one place so you can use it. So we will have a fully connected layer. The fully connected layer, they're going to bring all the knowledge back to one place. That knowledge is the features that we're going to learn from images. So please look at for the fully connected layer. And the fully connected layer is in the bottom of convolutions and fully connected. You can search for it, or you can basically look and find it out. Go drag and drop it and connect it to the max pool. There's some information we need to change on that, but then we'll come back later and change it later. So please connect it back to the max pooling. Before we actually then ask the computer to go and classify, we need to do a last normalization, which is called softmax layer, right? So again, going back to that lecture, try to remember that architecture because you might have an exam question on that. So let me go and find out the softmax layer, which is in output. So we're going to drag and drop the softmax layer. and you want the computer to classify the image for you, which is called classification layer. So you will have fully connected layer, softmax layer, classification layer. So if you look at your network, like what we discussed in the last session, we said that a convolutional neural network, you will have an input, you have a feature learning, which a feature learning is a comp to these, basically the normalizations, the ReLU, the softmax classification. And then at the end, once you're going to do the classified, always 3 layers. Fully connected, softmax, and classification. Sometimes it could be basically the flattering the features as well, but that's a good. So, on your right-hand side, it says your network has how many layers? 16. Great. So if somebody asks you how many layers your network has, usually you don't say it has 16 layers. You will say it has 3 deep layers. And that 3 means how many convolutional layers you will have, right? Because the rest doesn't do any processing. You will have 1 convolutional layer, 2 convolutional layer, and 3 convolutional layer. The rest is the basic processing on the output of those CNX. So if in case and then in your presentation, me and Robert ask you a question on that, make sure you say that only how many deep layers. Right. So, few things about this software. Probably, I think now all of you have a network which is not nicely laid out. If you want to have it really nicely, please click on auto arrange, and then it will arrange it in a basically a vertical. So you can picture a screen, you can present. The other thing which is really good is if you click on Analyze, it's gonna go through and try to analyze your network. I will tell you what's wrong with it. The beauty of also these tools, it gives you the architecture of your network, which always whenever you present, you need to have it. Whether you're writing a report, whether you're doing a project, whether you're basically doing the coursework, this is the architecture that you need to present. Each layer gives some value, right? Each layer basically there's a value in front of it. So that's really important. Usually, for instance, if you will have a technical meeting with the manager and so on, this is what you can share. We'll tell them what it is. We don't need a picture screen of this for coursework, but we need a picture screen of this. And you will see you don't have any errors, you don't have any warnings. If you didn't connect the networks and so on, you will get them in here. I intentionally put one mistake, and we will talk about it later on. So you will see how smart is the software. So, yep.
275K animals. Does that mean like the number of images you can take?
Variables, yes. So now we have everything. We have our network architecture, which is always the first step. Now we're going to load our data. So please click on Input, or Data in my case, on the basically top toolbar. Please click on Import Data, and please click on Import Image Classification Data. There are 2 ways that we can load the data. If you already have a MATLAB code that goes through and creates a set of data set, you remember that 2 weeks ago we talked about it. There is an image data store. You remember where code on that. Then you just need to just click on, instead of folder, we change it to image data store in Workspace. It's automatically going to go and look at this. Today, because we don't want to use code, please click on Browse, and please find the location of the images that you have saved. Mine I put in the desktop, and I called it vehicle dataset. Make sure you don't go to each class. You go to the top folder of it, which just says vehicle dataset, and click on select folder. On the left-hand side, there are augmentation options. We don't need it now. We'll come back to it later on. On the right-hand side, of the other side, we will have something called validation. Do you remember what percentage we used last time for validation? So think about it that you're gonna have an exam, right? There's 1,000 page, or there's let's say 100 page. How many pages you want to actually practice in class, and how many you want to keep for basically exam? They have 100 bank of questions, 80-20, right? So 80-20, probably 75-25, or maximum 85-15. So we're gonna do the majority of it for practicing. Same thing for network. We're gonna keep maximum in here 20%, and we talk about it must be randomized, and we talk about the reasons, right? Because if you don't randomize it, let's say you have 100 images, right? You don't know how they organize it. They might put, I don't know, a sedan car for the first 80, let's say the SUVs on the last 20. Network struggle. You might have males on the top 80 and then females on the last 20. You need to randomize it. I'm talking about it. There was major issues with the basically military equipment. They've done the same mistakes and so on. It must be randomized. Once you do it, please click on import. And the software gonna go and import the images, but also provide a graphical representation of it. And randomize. So something which is really important. We said the number of images in each class is important. What is balanced or not is quite important as well. The tool is doing it for you. If you are talking to your manager, if you are presenting it for your coursework, you need to have a picture explain of this. Few things is telling you. Do you see any class that has a lower number of images compared to the others? Which one is it? 5. Great. And the tools is also telling you. Bikes has 80 images, whereas motorcycle has under 60. Which means an AI going to go in favor of motorcycle, which is already challenging because motorcycle and bikes are quite similar. Ideally, what you need to do, you need to increase the number of images in the bikes and make sure they're all uniform. Ideally, you don't have to. But ideally, you need to do this. So for instance, I was doing a project with a student. Here is doable, but we had a class with only, I think, 150 data, another class with over 1,000. Definitely they are going to go with it in favor of the one with 1,000. So that's what it's trying to do. So other things, you don't have to go to the images. In here, you can go and select different classes. You see my sample images of bikes, my sample images of cars, my sample images of motorcycles, the sample images of the pedestrians. So just click on each class. So we will see that in here that most observation is a motorcycle, 160 images in the training, and bikes, 80 images in the training. This is your training. We said 20% of data for validation. Please click on the data, change it to the validations, and you will see the sample images in the validation category. So what I want you to do is basically picture screen, the training, and the validation for your presentation. So you can basically explain the differences between those two categories of the data. It will tell you how many images you will have in each of them, and so on. Is it clear so far? Yes?
Yeah.
Great. How many classes that we have in here? 4. Great. Keep it there, but remember this value because we need to come back to it. Let's say you think everything is ready, and now we're going to train the data. Please click on training, and please click on the play icon, which says train. Let's click on the train, and you will see you get an error. The software is smart enough, if you make a mistake, to tell you what you've done wrong. Please read the error and tell me what's the issue.
is invalid training data, the output size 10 of the last layer doesn't match the number of classes of the response 4. Right, so we said we have 4 layers, but it seems in your layer you made a mistake, which is 10.
Please go back to your layers, and please to go and find out which layer you make a mistake and you keep the 10 value. So start from the last layer. Classification output is what? Automatic, right? Good, you're fine. Go to the layer above it. Softmax, we cannot change anything else, right? Go to a layer above that. Fully connected layer. Do you see an output size over there?
Okay.
Right. So the output size should match with the number of classes that you will have. So that's 4. So in coursework, if I give you the 5 classes, it becomes 5. If I give you the 2 classes, it becomes 2. So change this. And go to the training and click on train again. Remember last time we've done this through the coding. This time we didn't even write a single line of code. That was only to load the Deep Network Designer, which technically even you don't need that code if you have a compatible software. Just click on that code. So what you're seeing, the network is struggling. In your case, it's thinking the network will start to struggle with something like that role. And I start to. Do you know why the number is going down? Why is it declining? You had a really good accuracy, the network was learning, the boom is learning, and then suddenly it dropped.
Because you started adding more stuff on
Really?
The fact when you go to 16.
So what it's doing, each time it goes through the all layers, right? But it's not that actually I'm going to do the first session in the class, and I will tell you how confident you are. So I know I can go to an exam. You go to an exam and it's better. So it claims that I know everything, and then had a mini quiz. And then the quiz couldn't basically do well. So the network going to learn from the mistakes each time, right? So once you have a network that doesn't eventually learn and struggle, that means that you need to change parameters. We talked about those. Remember actually 2 weeks ago we talked about the minimax size, there was the initial learn rate, and so on, right? So what I want you to do, for instance, in this case, I've got 72% accuracy. Once this one is finished, please click on training options. And we're going to go to the training options and then change the values. It's okay, the network doesn't learn, just pause these. And pause this. So that was the majority of my, first year of my PhD was keep changing the values and so on. So please go to the training options. And this is what we basically used 2 weeks ago. So the initial learn rate we said is how fast the network needs to learn. For instance, if I use 1, that means that all the basically the examples and everything going to deliver in 1 session. You want a slower rate, right? If you had the numbers, probably 0.01 was fine. Because you had the numbers with a black background, right? Quite simple. Your images are not simple. You have pedestrian, multiple people, busy backgrounds, different type of cars, and so on. So you need to do a little bit slower training. So think about it. If it's a really complex object, you don't expect it to deliver in 1 session. You expect it to do it slow. So we're going to make the network a little bit slower, which means you're going to add 1 more 0 to the end. Becomes 0.001, e to the power of minus 3. If the network has struggled, then we're going to make it even slower. We're going to turn it to the e to the power of minus 4. If again network is struggled, we can also deliver it down as well. Almost probably for your coursework, it's the e to the power of minus 3, e to the power of minus 4 will be sufficient. We have something else called mini batch size. Mini batch size means how many images and each time we're going to feed to the system.
How many images do you have in each class? I think 118 was the highest one, right? If I use 118 in one go, I lose all of my images. You want actually going to spend all the images, deliver everything in one session? We're going to do it gradually. Right. So, ideally what we do, we just plan and then use different values. We use 8, 16, 32, 64, 128, and so on. And my recommendations, depends on what is your computer, don't go above 256, 256 and so on. You will see you complete that. Because you have a big images, it cannot process, and each time we're going to take it to 3 different processes. So, what was the lowest number of images you had? 80, right? That means the highest number of images you can fit at the top shouldn't go over it. Because if you do it, one class you use all of the data in one go, but it's still the rest there are images, but not from that class. What you're going to do, you're going to find an image. For this one, let's go and use 32. But again, we can come back and change this anyway.
Do you remember what was the epoch?
Say 32 for the yeah. So at least I was thinking probably it's gonna have 2 rounds of the bikes, which was 80, but yeah. Go through that. Epoch means how many times again from the beginning you want the network to go on there. So more of that means what? And then do you think it's gonna increase my accuracy? Yeah. And then what I lose on the other side? What would you lose? Time, right? So it will be more time. So you need to find a balance in between. Let's go with a start with a 10 and then we can come back and change it. So let's say 10 times we're gonna start from scratch. If I need it that high, I'm gonna lower it down. If I need more, I will increase. And there is validation frequency. How often you want to have a mini quiz? Mini quiz is really good. It helps the students to learn. It helps the network to learn as well. So by default, the thing is every 50 iterations. I would say change it to 30. Usually 30 iterations, it's better.
You don't need to change anything else, but few things that's good to know. If you click on mini batch size, and then you will see every epoch you're gonna shuffle. That's really important. If you don't shuffle every epoch, what happens? Same data, each time network gonna see. Right? You don't want every session I will come with the same sort of lectures, right? You want each time I will go through a different type of question. The other thing, which might be helpful for your coursework, is a hardware. MATLAB by default, keep it on auto. If you have a computer which has a good CPU, but you don't have a gaming, basically, like computer, or a computer which doesn't have a proper GPU, use CPU. If you have a computer which has a good GPU, force it on the GPU. These computers, they have really good GPUs. You can force it to the GPU, or you can do that also. MATLAB will pick up both. We will see which one is the best. Once you join industry, hopefully, you will see you have an options, or if you have a really good laptop, you can go and use multiple GPUs. You will have basically an external GPUs, or you can use parallel. Which means you're gonna then put in all the GPU cores, all the CPU cores at the same time, but most probably you cannot use that computer because at the same time it's quite heavy. I keep it on auto, but sometimes, especially if you are doing a final project or industrial project, you're gonna force it to the GPU. Make sure you get a high accuracy. So I don't know whether you're going to use your own computer or going to use a university computer. It depends on the room. Sometimes it forces on CPU, sometimes it forces on GPU. Right? So I'm going to keep it on auto. And now please click on OK. and train again. So you're gonna discard the results that we already have, and you're gonna go through and basically do the training again, and hopefully this time your network will show you promising results. And that's a fun part of it. That will really relieve when you see your network is learning. But there is some issues. The blue means training, and orange means an error. So if you're coming from MPC, you always want the convergent results. Here you want the divergent. You want the error to go, or loss goes down, and training goes up. You see black lines there. What's the black line? Have a look at the religion. Well done. So the network is claiming, in your case, for instance, that I know 95%, go to an exam and get 80. Network is trying to learn, but it's still a struggle. What do you think can be the cause of it? Think about yourself. You're going to go to an exam, you think you know the contents, but you go and then you don't perform well. What do you think you can change?
Wrong images, maybe. Right, you advise the wrong stuff. Increase the validation.
Validation can help, but it's still validation, which you will have a mini quiz earlier here, right? Which is not bad. Eventually, then we're gonna learn. Good things. Sometimes there is feedback, right? Does your network is learning or is it stable? Right. So not necessarily epoch would help, right? Epoch would help if your network finished there, right? You want the continuation, you need more time. So epoch in this case doesn't help, but sometimes it's the case, right? So you're waiting for your course. Yes, what else?
There might be the images that you would like for training at home.
It's random. Random images. Which can be the case, by the way. So if your network is struggle, not on the first time, if you keep doing this for let's say 10 times, you see your network is struggle, go and check your data set, because you might have a data set that is really confusing. You will have different type of images. You will have, for instance, I had a student that some images of the car was in front, some of the images on the side, some of them on the left, so the network get confused. In this case, what do you think we can also change?
You have more images.
Yes, you can have more images on one go. Yes, well done. And you can also change your page. You can do a little bit of slower learning, right? So 0.1, for instance, and minibacks. So do you remember these things? So we said epoch we need to change. We need to then think about the minimax size. We need to think about the initial learn rate, and we need to think about the validations as well, right? We'll come back to it because it gets challenging at some point, but then there's a solution for it. So go back one more time and don't change multiple parameters. Change once because you don't know what's wrong with it. Just make the network a little bit slower, 0.0001, and give it a go.
Is this like the independence sort of? This is what you call the 500 parameters optimization. One of it is very complicated. So losing a network is slower. The time of it is increased, but the black ones are getting a little bit fuller. But you're losing so much time. The black one is supposed to be right in line with the yes. If it's under that, the question, we call it basically underfitting. If it's more than that, it's called over. Your network shouldn't have underfit, your network shouldn't have over. Which means that you shouldn't go to an exam and say one company is 60% and then in the exam you will do 90%. What does it mean? That was your luck.
So it's exactly the same as blue line. That means finding 90%.
Yeah.
No, not necessarily. So your network can say here is 90% and then this one is 90%. So that's a fit sample. So both cases, really good. Let's say you're going to continue, still you will see underfitting, right? So the initial level didn't help me in this case, right? If in case I'm going to force myself so the network will learn more, what do you think I need to change?
If I'm going to keep the initial learn rate as it is, don't touch it, but the network is learning, what you will do? Well, you increase the equal, right? Because the network is learning, right? But in this case, I know if the network is still learning, there is gap. The network doesn't learn anything yet. That means that I need to have more data this time. Another solution. So we said 32, give 64 images, for instance. Lower the initial learn rate again, 0.01, and instead of millibytes of 32, make it as the 64, and train again. This is a majority of your work if you're working on AI. That which was an issue. The majority of the students that I had in this university, they did a really good work on myself in the final project, or they failed. Because you cannot do blast with it, it takes time. And that's the simple images. The actual project you're going to do, we're going to be terabytes of data. Each of your simulations will be days. For my PhD, was 3 weeks in the hard performance computer. So think about it. If I didn't do a strategic decision, let's say this week, many batch and so on, and I was doing, I think, over 500 different iterations, different combinations of values, it would take years. So you need to be more strategic about it. I'm going to give you a good number of images for your coursework, so you don't need days of it, but at least you need, I think, half an hour to 1 hour of training. So you can actually down the numbers get slightly closer, but it still doesn't solve. So, what does it mean? You're going to need to keep doing it, probably 10 times. If it didn't work, what do you think is the issue? Which is the issue in this case?
Data slow. Change everything but the images.
So do you remember that we talk about the network architecture? So in the slides that I showed you 2 weeks ago, said actually the network will have an image inputs, it's feature learning, which is the convolution layer, the Bayesian normalization layer, redo softmax, and you keep doing it a few times, and then you have fully connected layers, a softmax layer, and an output. Did I tell you how many layers your network should have?
On the screen there, it didn't seem like that.
Yeah.
Wow.
You decide on the layers. And that's the billion-pound value of the Teslas and so on. Damn, which is really unique. Right. So you're gonna go and then keep decreasing keep increasing the top network, more layers, from 64, 128, and so on. For the coursework, probably you need to have 5 to 7 deep layers. It's not enough. Right? We don't have a time for going through this, but we're going to move on and talk about something else.
So you would basically just increase what we made before.
Yes, convolution, those 4 layers you can copy. Right. Okay. So, one step of your project which you need to present is this one. This is called creating a network from scratch. That's for step 1 of the project. You do a little bit of the optimizations, and you will say, this is my network. So think about it. I create a network for the same data set, and I get 80% accuracy. Right? You will do basically another network, get 85. You're going to do another network, you're going to get 90. Your friend going to do another network, going to get 95. That's the novelty of what you've done, right? But this will prevent the growth of technology, right? Because each of us, we have a different networks. We don't have any things actually we can rely on. That's why at some point, the scientists decided, let's share our network with each other. If you have a network that you don't know how it works, why you don't give it to me? Then I will go and work on beyond that, and then you work on your network on top of my model. This is called a pre-trained network. So the network that is already created by the scientists, that is publicly available for people to work with. How you can publicize it needs a same data set. because otherwise if you then do it on the apples, you do it on the orange, they're different, right? A set data set. So companies decided to create a data set. One of the best one at the time was ImageNet. 1 million images, 1,000 categories. And that became a benchmark. If you had a network, every year you had to compete in this competition with the same data set and you had to say what's your accuracy. For the last decade, people done that. And if you go to your, let's say, designer and click on new, please click on compare pre-trained network and have a look at it to the networks that the people for the last few years, they created for you. Can you see the differences between them?
Yeah. 200 values. Yeah, 0, 1. That was it. Very simple.
So please go to the graph that this page shows. So these competitions started with a network like Squeeze Network ADAS. What they were promising acceptable accuracy, technically no need of GPU. They're publicly available, so they started using that, and then I started to retrain. Let's say for cars, you started training with the banking data and so on. Each people are different, but they compete and they become the number one. Because of the growth of technology and that competition every year it exists, and every time you log in here, companies like MATLAB or Python, they try to actually implement these in the networks, you get a higher accuracy, but what you will then need is a number of GPUs. So, if I tell you, you are going to make a neural network for a car, you're going to go and identify objects on the road. Which of these neural networks are going to pick? Nothing, right? If you're working in biomedical world, which is a high accuracy, you're going to find out the cancer, you're going to go with an AST. What's the issue with that?
Too slow. It's not higher GPU,
right? That means that can you afford to put 20 GPUs in each car? It would be just 40,000 pounds of the GPU just the car. So you need to find a balance. None of these computers cannot handle those networks. So I had a project students using these labs. Any network beyond the ResNet was failed on these computers. As soon as you run it, it crashed because we don't have GPUs for it. So you need to find a balance. It's quite similar to your meshing, right? You used to go with a really low mesh and the computers work. So one of the best networks till this stage, which has a really acceptable accuracy, is called GoogleNet by Google. So if you see the GoogleNet, it will give you over 65% accuracy, 65 to 80 range, guaranteed if you do it properly, and then you can push for more with what? With optimizations, right? If you have a good computer for the courseware, you can afford basically using some GPUs or LRC computer with these labs, you can push for VG19 because VG16 and 19 is quite similar, but probably 19 is better because it's more. Your pre-trained network for your courseware, you will decide which one you're going to pick. My recommendation is start with GoogleNet. Most probably you get over 90% accuracy if you know how to do it well. If in case you end up in industry, that becomes your number one, but eventually got to go up. If you're doing in banking, you can afford to have this because the time is not important for you. Just do it once. Because once the network learns, that's your network. Then in milliseconds, they're going to decide, right? It's just a training part of it. If you're going to have it on the car, depends on the price of the car, you're going to then see whether you need a GPU, you don't need a GPU, and so on. Right? So these pre-trained network, the way that I explain it is like this. A technique is called transfer learning. What a transfer learning means, rather than give you a network from scratch, I'm going to give you a network with some pre-knowledge. So think about it. I'm going to teach this one. Can I teach it to the toddler? No. The scratch network that they created was a toddler. He didn't have any knowledge. Do you think I can teach it to let's say a 18-year-old or someone just joining university? Yes. If I go with quite a slowly. 18-year-old is equivalent of Google. Not a large is a proposal, right? So teaching that level of knowledge is much more easier. Their downside of it, I don't know how they trained it, and that's where they talk about ethics. You rely on somebody else's strength. If the system was racist, you continue with that, and you hide it. There was cases in IBM. I think I've talked about it. They went with, let's say, the male CVs for jobs rather than females because that was the way they've been trained. They had more CVs for the males. Right? We had it with the for the facial recognition, the different skin tones. For quite a while, it was only the basically the Europeans, blonde, white, for quite a long time. Until they said, I think it's quite important. We need to fix it. Multiple gender, different skin tones, different basically the facial hairs as well. That's really important because otherwise the network gets confused. All of these, the beauty of them, they've been through that process before they get there. So next day, by the end of the module, you're crazy enough, you can create your own network, complete its compilation, and then you have an IM first, you can defend it, submit it to the MATLAB, and it has a good network. So let's start with GoogleNet, and what I want you to do, please click on install on GoogleNet, and it asks you to go and log into your MATLAB. Hopefully you have a MATLAB account. So you're gonna go and then bring your basically network. In this case, I already have these. So you click on replace.
It already has it.
What does it do?
We need it.
It loaded for you.
No, I didn't load it. But what does it? It just says it's over. No. So if it's working. Yeah. This one's. That's just the anchor transfer. You can go on this. Limit 7 have it. This is G. You can do the add-ons in this one.
You have the movement as well on your computer, which says install, so it's managed. Does manage or sense install?
Manage is
So it says you already have it, right? Work, and I will give you a swift net rule start with that, but that. group extent and several stuff. Hopefully we'll install it because that's a quite a powerful network. If not, we go with a squeeze net, a basic one. Does the job, but I mean it's good. Close this one. This for impact. Could you use it to like train your own? Well, I think so these we'll find out better than the next class because basically we can look for is more for clustering. So we can find out on uniform patterns. We group the data. So these are the charges trends. We can find out for instance, I know in OD that will find out something actually doesn't make sense. We automatically find out that group doesn't have a logical. I know that for instance for traits, you can give them a graph. We can do a prediction for you on that. The graph is quite similar to what we use to find out whether the driver has sports static or we use it. It learns the pattern. So earlier than any medical doctor, it can tell you whether you have heart attack or not. This is how the Apple Watches can tell you to start breathing before you have heart attack, usually 20 seconds in advance, because see the patterns that usually medical doctors don't see. It's the issue with the cinema is only image. It's the most powerful way of doing image processing. Yours, unless it's a graph, it's image. If it's numbers, then you're gonna go with a more clustering approach. It's a numerical approach. I don't know, for some reason this one doesn't work. So let's go to the SqueezeNet for now, and then we'll later on we'll go on and do the MATLAB. Go to the SqueezeNet. I'm gonna change my network in here as well.
New SqueezeNet. Replace, please.
So you can see that actually SqueezeNet so has 68 layers, and Google has 144 layers, so they are deeper and deeper, and that's why there needs more GPU. Google Net need more GPU than SqueezeNet. This one probably 1 or 2 GPU will handle. So 1 core GPU. Please have a look at your layers and tell me what you think you need to change. You can zoom in to have a look at it. Think about it. If you're going to use this network, it's been done by another scientist, and you know it's reliable, you're going to get a good accuracy. But in order to work with it, what do you think you need to change in these layers? Okay, good. Go to the data image input. No, I mean the first layer. And it says the size of image should be 227 by 227 by 6. That was the same in your case, right? Let's say you don't have an image in this stage. Yeah.
Are they like a certain image or like a 227, 227, right?
It's the width and height of it. It's the pixels.
Well, the angle.
So if you don't have an image in this size, you have to write a code and convert the size of your image in this. For a coarse code, you don't need it because this tool will automatically resize for you. But if you're doing a Python or if you're doing MATLAB coding, they don't have that option. You need to resize it. So that's the first thing. That's why your course code says you resize. Resize means computer will do it for you. Other issue that unfortunately is a limitation in here, it says depth is tree. You have to stick with the tree because if you don't do all the calculations afterwards, that goes wrong. So that means if you have a grayscale image, you can do this grayscale, but you need to write the code and put it RGB format for review. So it looks like black, but in reality, it's taking RGB. Okay. Is that okay on this one? You don't need to change anything. You remember that the network that we created, we run it and we got an error. What did we do in order to solve that error?
Is it bottom?
Well done. When we use a pre-trained network, you go to the last layer. Go to the last layer. And tell me what is the value of the classification? What that 1000 means? It says ImageNet benchmark 1 million images, 1000 categories. Every single of us which contributed to that data set, you know that.
What's the boost out part of it?
Google captures. For years, we were telling which one is a chimney, which one is the cars, and so on. So this is how they collect the data. So we as a human basically would then select them what they are. So you used to see 9 of them, and from those 9, basically 6 of them was known to the network. The 3 others, every time we just keep basically annotated for the Google, and they collected those data.
That's something that you found a picture of yourself. That's people, yeah. Okay, something.
These ones, yes, if they don't have. So every single image they use, they claim that actually is open source. It was, so they went through the, I think, Flickr and so on, so there are basically different kind of copyrights, so they only use the open source one. They didn't use any image on these data that was a copyright. Which is a big issue. They say right now, with the large language model like ChatGPT and so on, the way actually then create images, it actually doesn't go to the open source. So sometimes go to basically.
What's actually get like the software and like the way the brain across the camera that we're going to have like a lot more data to be working with. That's a lot more compromised.
Not necessarily, you collect the data. You're allowed to go to the street and report people.
Some people can say that legally.
I think you can film anyone in public.
Yeah, we can film anyone.
Or it depends what we do.
Yeah. But you cannot get the data from you while you're driving the car. So that's why the Tesla, if you're driving, there's a camera to see your driving status, but you can switch it up. You're not allowed to use your data. You can't allow to get your data, anonymize it, and then train it. This is, as a user of the autopilot, you basically authorize it, but they are not allowed to actually, without your authorization, to use your data.
So why can they use the picture of someone outside of it, not the picture of someone inside of it?
Inside the car, because that's part of it. Outside is a problem. So you can go to this really try and put in on. The captchas, is changed. So the captchas doesn't use this format. So the captchas now doesn't look at what image you select. Look at where you move your mouse. Good. That 1000 in a previous MATLAB, you're lucky you don't need that. You had to delete, right? You had to then cut and then go and bring the layer. Now they added the feature is called unlock layer. If you're using MATLAB 2023, it didn't have unlock. You had to then delete and bring the new one. But this case, there's an unlock layer. Click that, unlock it, and that 1000 become automatic. So take a note. We need to change the last layer. Is that clear? Great. Can you go to the layer above that? The softmax layer. Can you change anything there? Great. We move on. We're going to go to the global average. Can we change anything there? Great. We move on. ReLU, can we change anything there? Great. Conv10, can we change anything there? So, can you tell me what is basically the number of filters that you will have over there? And that's an output of it, right? We need to come back and change it, but that's okay. Let's keep it there. I'm going to see the errors. Go to your data
Your data should be loaded from the last time. If you haven't loaded it, go and load your data again. And then I will tell you how you can get your yeah. You don't load it. And I'll save it as well. Sure. Folder. The rest the training. And make sure.
I forgot to randomize it. Can I change it?
Yes. Yeah.
So
No, I'm sorry. Yeah. Yeah. First one. Yeah.
I've already.
It's okay.
It's fine.
Great.
It doesn't like double it up.
No. So please go to the training. And for training options, you remember that actually we talked about few values. We said the initial learn rate, we think it should be 0.001. We said that initial learn rate should be around 64. And for the epoch, we're going to keep it as 10. Right? So click on OK and let it train. It's a more advanced network, so hopefully give me a higher accuracy. If I get a low accuracy, less than 30% means something is wrong. Can you see the error that it's showing?
It's the same as before.
Great. And what was the layer that we didn't unlock? Well, go back and change it. So my recommendations, don't play with the networks until you see the error, because it tells you what's wrong with them. Because you don't know how they design them, especially if you're going to go with a really advanced network. Go to the convolution to the unlock it. 1,000 output needs to be 4. Go to the training, click on train, and it hopefully starts to learn. If it gives you another error, you go and then change it. So what's quite important is the free train network, don't mess up with them. Don't change any other layers. You don't know how they calculate it. Classification first, become auto, and then convolutions become 4. If you're using the Google Nets, it's called fully connected layer. It's not called convolution layer. It's called fully connected layer. But you know, they're the same.
So this is how it's going to be open. Okay. And here, so when you have to change that. Okay.
If you want to use this for anything, then so you could like literally import any rule, like images and
Absolutely. You just need to have few hundreds of images.
Yeah.
Ideally, so think about that example: 1 million images, 1,000 categories. Each category should have 1,000. This is the best thing for AI. So that's why you remember the numbers. We had 1,000 images in each class. That's ideal. If you were doing a project with me, you had a few hundred. I would ask you to go on and increase the data in each class to 1,000. You can talk about it in your presentation as well in here. But the data I will give you, I don't give you more than a few hundred in each class because I don't want you to waste time on this. I know you have a choice to do. But if you end up in the industry, any class less than 1,000, it's quite risky. And that's why the companies go on like millions of data. More data, it's basically more knowledge. So think about the example that I usually use. If I show you, let's say, if you give a toddler a pen and pencils and so on, and then suddenly show this one, we'll take some time for a toddler to find out this is a pen as well. What it's going to do, it's going to go and look at it to see whether what kind of feature of this is quite similar to the toddler. From now on, if you remember this,
So that's why you need to give more case scenarios to the AI and keep learning. So if you're gonna only give the sedan cars, if you see SUV car, it's wrong. Unless you're gonna see the basically the SUV cars and so on. I started recording this. Hopefully my computer doesn't crash. Your coursework is identical to this. But as I said, it's a difficult coursework. Don't put it on last minute. And there's no way you would be able to do it last minute.
When was it due again?
End of the month. Last day of the month is your presentation. Yeah. Great. Have a look at your network. What's your network accuracy?
Really accurate, 99.24.
What you've done? Did you randomize?
Probably take some time.
What you've done for this?
It's pretty close because the black line and white has to.
Yeah, but that's quite close, right?
It's gone from.
You haven't done anything. You just inputted data. You use somebody else's network. You run it, and you have quite a confident network.
There's a part of it that I don't understand.
Yeah. Let's wait for it to go. The only thing if I'm gonna go on and change, I will go on and add more readings.
Yeah.
So it doesn't so far since do you need more epoch? No. If your network was intelligent still learning, you need more epoch, right? And we talk about underfitting, overfitting. Yes.
But not in this area.
It's ReLoop. So ReLoop what it does, it says that any value above 0, keep it, any value below 0, forget it. It means get rid of background. Ignore non-important informations. So your network is deep, but sometimes become horizontal. So horizontal, you are not learning more, you get rid of the information. Right? So for instance, in the Google, you have more of this. Why you have to do it? Because the network is getting deep, you need to get rid of information to learn, and get rid of information, because otherwise you cannot go 68 layers down. Right? Yeah. And so also there are some which is called clustering. So you're gonna put all the features in one basic place and then figure it out.
Right. As you go deeper, then you look at something's clearing more.
Because otherwise it's going to be slow. So, did you get this one?
How do you say clear slow gap? Any more?
You can quickly because then this. Okay, if you think before we move on, while your system is learning, for your coursework, and anytime you do a presentation, that's compulsory. You have to show your training plot because training plot will tell me whether your network is learning, whether it's overfitting, whether it's underfitting, whether your loss is going down or not. That's really important. Otherwise, none of the claims is not acceptable. You cannot say I've got a high accuracy without training. Right? Few things you'll need to have a look. Your network accuracy, your time. If, for instance, you tell me that you've got 97% accuracy in 1 minute, and you told me you've got 98% accuracy in 10 minutes, for car, which one do you think should I do?
Most one.
So I sacrifice the accuracy. From student AI competitions, my team came with 98% accuracy, perfect. The car was driving with 6 seconds delay. And think about it, over 21 per hour. That's a huge. So I told them, reduce the layers, but it's at the accuracy 70%, so fine. There's no one in the second, you just drive. So then we're going to do the high, basically, really fast speed. We finished it, accuracy was low, but that's fine, the car can cope with it. Of course, you don't want to then tell pedestrians, right? But you just, the car needs to see an object, doesn't necessarily need to know what it is. So if you get even 80% accuracy in lower time, is acceptable. If you're going to do the medical work, that's it. If you want to find out someone has a chance of not, time doesn't matter, it's accuracy, right? So that's the balance. What you need to do, anytime you present, you need to picture screen these. People were lazy, that's why they actually put a picture export and well, we basically picture screen these and say this. So it's really don't improve basically software. If you want to increase the gap in here, decrease the gap in here, you go to the training options. I'm gonna change the validation frequency with that value steps. So every 10 iterations, if you're going to do it, train, you will have closer time. So let's see what's wrong.
Is it management?
Yes. less characteristics. Because one fabric has only 80 so that this one only has 80. That means the rest of calculations without box, you finish all the data in one row. So gonna lower the number of images you have, 64. If I copy that down to 10, how many times we're gonna do from beginning? 10 is not. 60. It's really fun, but then if you end up, well, I can put it like that, that's true. You need to be patient, keep doing it. I will tell you, there is a way that you can use AI to do that for you, which is really neat. That's I lost 4 years of my PhD.
That's about where shouldn't evaluation be but why is evaluation higher than the
Not quite. Usually it's a network design and only 20% left on the exam. So that's why that you're basically taking the exam shouldn't be higher accuracy. That should be quality basically also fitting the long of them. Are you okay on this one? Okay. So once this one is finished, we're gonna move on. There are a couple more things on this one, and then I'm gonna start the cool part of it, which is seeing what the network actually see, how the code works.
How much different is it if you want to train on, I know, like books or like bodies of writing instead of images? So you know how, like language models. Yeah, exactly.
So this works with images and input. Sorry, input is an input, right? For there, the input is a text. So it's a different process of it. Instead, it's a similar neural network, but it's not convolution. It's not a matrix that's moving. It's a different way of it. So what they do mostly is about similarities between different words and sentences. Right? But feature learning, what's it? So let's say you have these things, and you're gonna then work for a company. Techniques from EPL 6 onwards basically, right? Just spend more time, but the network doesn't let. What you do, you go back, reduce the EPL to 6, and then your time reduce. That's the body. But if your network is learning like this, you have to let it back. So that's what usually going to become 30 and so on if you go with a really low initial level. Okay. Great. So
see, the accuracy is still pretty low. Not done yet.
did you check any other layers? So can you please go to your images? You're lucky because you're lucky because actually your network accuracy is acceptable, right? So you don't necessarily need to do anything more on this, right? Well, let's assume you got a low accuracy. And one of the conditions at the beginning we talked about, we said there's an issue with the data set, right? If you have a data less than 1,000 in categories, AI can struggle. Doesn't have enough samples, right? Have a look at some of these images, go to each class, and see the different type of images over there.
People have like different like enablement. So say if someone's in like a wheelchair, or someone has like, I don't know, different kind of like body structure. How do you train them on that? Like you just have to make different tasks.
Well done. What do you think you should do? Really good question.
I'm assuming on that one, I can't remember this the other day people with wheelchairs.
When you're driving a car, do you actually care whether the person is on a wheelchair? No.
How would you know it first?
So you put the people on the wheelchair images on the pedestrian. The car just needs to know it's a pedestrian. But it's a good case because otherwise it will confuse it with the bike.
So it just works together.
You put more data. And that's called generalization. So that's part of the coursework that I will ask you to do. So if I put, let's say, the car images only, there is no ambulance, you probably expect it's an ambulance, because I see my network get better.
Right, it's the same with some of the still on when
Yeah, but then that's when you have to go with a lower speed, you have to get distance from them. That's what the point is. You should actually try that. So it's better to put in a pedestrian. You can have a standard category as well, like this stuff here. Then take things into this. So if you see the images, going back on generalizations, you have a low number of data. Let's say in point, you have a low number of data in each class compared to the thousand images that you want to extract, right? You want to create some fake images. This is what we call a data augmentation, right? So click on the input data again. This is, once you've done your network, another step of coursework is asking you to do image data augmentation. Go to the data, click on input data, and underneath that, when you load your data, it's called augmentation options. Please have a look at it to the augmentation options and tell me, what do you think they are? What do you think that they, what case scenario do you think that will be beneficial? So you have the images of the car, which was all like this, right? If you see the images of the car, it's like this, right? The car is not always like that. It can always be. You can give an angle. If you want to train a driver face, with an angle, right? You don't have that data. You don't have time to create data. You have solutions. Data augmentation. In data augmentation, you have something called rotations. I can generate fake data with this image with angles. What angles you decide? If it's a face-up person, usually minus 30%, 30%, because you cannot go beyond 180, right? Put minus 30 to 30%. When you are driving a car, do you always get the same distance to the car in front? Or sometimes you're quite close, sometimes you're far from it? So that distance changes the proportion of the image, which is real scale. I would change it 1 to 2, right? I don't want to have a drastic change, but then it can be 2 times zoom, it can be 1 time. But again, in your course, we'll do 5, for instance, if you want. I don't know. When you are driving a car, an object in front of you, you want the pixels. Let's say this, I don't know, let's say the headlight will jump from here to there. No. So you don't play with the pixels moving. When you do with the pixels, when basically the background, it's basically you're sensitive with the background, so you want to actually then knows when the pixels goes around, you can play with it. Otherwise, you shouldn't touch it in your application. Always, basically, car is gonna be, let's say, like this, or gonna be with this one. Let's say you have an image like this, or it can be like this as well. So this satellite will go there, this satellite will go there. Does it make any difference? No, but it gives you more image, right? That will be your random reflection axis across the y-axis, right? So an image like this, you can like this. If you want, you don't have to. But like the last year students, again, you can he defended it as in his report. So, do you want your network to be conventional car like this as well? No. So then you don't need x-axis, right? You need a y-axis rotation. Yes, this is how he defended it, but I think he was quite clear. He made a mistake instead of y with x, but then he justified it when he was explaining it. You can put x, but I don't think your network should pick that.
So put a y-axis rotations. So let's say you had 100 images. How many more images you're gonna generate now? 1, 2, 3. So 100 image you have, I'm gonna create 300 fake images. I will have 400 images in total. I basically increase it by 4 times. Downside of it, my fake images are heavily more than my basic images. What does it mean? It means that actually if an AI only see, let's say, these traffic lights, it's become sensitive that all the traffic light is yellow. Unless your images will have a white, black ones. That's what, for instance, for training, we have different colors on it, right? So don't overuse data augmentation. Data augmentation is a quick solution if you don't have enough data. Ideally, you want to avoid data augmentation and use a buffer data. Okay? So for instance, for your project, there's an extra mark on that. All the images that I give you is in the morning. Try to find some images in the night. Try to find out some images with the noise on them. Try to find out images in the rainy weather, snowy weather, and so on. Right? Data augmentation cannot be. Okay? Great. Click on imports. The number of images wouldn't change, but technically you have a more augmented data. And once we're gonna get the code, you will see actually this is the code. Please go back and train again and see what's the impact of it on your accuracy. Did you change anything else after? Do you see how slow is the network? It has more in it. But if they want to with the data, then it's okay to it.
What's actually like training? Because this is like simulation. What's he actually do with the information?
That's the next one.
What? What's it? This way it's in there.
Overfit. You can see now it's overfit. Why? Because you're quite similar to the original images by lock. You get a higher accuracy. Technically, what I'm doing, I'm damaging my network now. Because you've got the really good accuracy. But then you will see for your coursework, because there's more time and data, it will be quite beneficial. The beauty of this network, you will hopefully see it, it's technically more generalized. It will present as more real case scenarios. Because none of your images didn't have angles, none of your images didn't have any scales. That means you need to spend some time on optimize this one, right? So there's a part of course where you talk about the generalizations. That's what it's done. So these actually now they are very well aligned before. They're over each other, whereas before was under. So you can say I have a high accuracy with the generalizations. I can still challenge that you don't have a day and night, but then at least the rest of case scenarios you call. So whenever you see an AI, always they talk about data information. It takes longer, but then more. Your network technically after epoch 7 now because your network gets slow. If in case you see that your network doesn't learn, what do you need to do? You go to the basically training options and optimize it. You lower your learning rate because now you have more data. You need less time. And whatever you were doing with the optimization basically. Good. Great. So now the fun part's beginning. You gotta say actually what the network is going on and what the network is doing right now. Okay? So for the rest of an hour, we're gonna do something that's the last part of your basic coursework that you need to do, which is, as I said, that's the tricky part of the. But you will see. I'm sure that once we finish the you will put photos on the internet about what we're gonna do with this. So. First things, once you have a network that you're confident with the network accuracy, and you have 95%, which is less than the previous time, but it's generalized. This is more valuable than the 97% here. Okay. You go and save the image of it. That's the first step, right? Once you do that, what I want you to do, please click on export, and please click on generate code for the training, where you see the magic happens.
How,
It's gonna write,
how you have something validation?
it wrote 200 line of code for you.
What new validation?
That's this. Validation. So that's the main business. You want every 10 to have main, right? Every 10. So go to your MATLAB. So that's the code that the software wrote for you. You didn't write a single line of code. It wrote 200 lines of code for you. And that tool existed before ChatGPT. It partnered with OpenAI. OpenAI asked them to keep it because it's competition. We had it for 2 years. I still never using. The only downside of it, make sure if you use this method, because you can just link to one first, not valid one. If you're using this one, you need to give me the code in the folder, not on the tenant. Because there's similarity between the style of MATLAB writing and you see you get over 8% similarity. Right. So I'm just gonna picture a screen. Let's go through the code and see what it's trying to explain. So we said we're gonna load the file, right? Quite similar to the activity we've done. First things, you need to make an image data store. From where? From the dataset that you have, and that's the location of the dataset, right? From that dataset, you're gonna keep 80% on the training. We call it image data store of training, and 20% for validations. What is important in multi-random? This is what it's trying to do, right? Then we add a data augmentation. If you haven't done data augmentation, you don't have this. Because you've done a data augmentation, it says, I've done rotations for you, a random -30 to 30, I've done a scaling, 1 to 2, and I've done the Y reflection for you. You already had a data set for training. I create a new data set for you. It's an augmented image data set for training, augmented image data set for validation. Size of images, 227 by 227 by 2. Right? Then you have the training options. Use auto, CPU, GPU, right? Use the initial rate of 0.01, use max epoch of 10, minimax of 64, and validation frequency of 10. We're gonna create a network architecture, which is called the L-graph, and these are each of your layers: image input, convolutional layers, redo, max pooling, and so on. And this is how you connect them to each other. So next time you don't need the network designer. You save this one, you come back, you have another project, or even the course, you're lazy, wants to do course with this one, you want to just change this code. That's it. And run the code. You don't need to do anything else. If you end up in the industry, most probably if you want to use AlexNet, that's your network. You don't have to use the Deep Network Designer anymore. Just make sure you save it somewhere that you remember. Let's save it to the desktop, for instance. Not just like I'm gonna save it. Wherever you want there, because we'll finish then later this. That's become your code. Okay. So save that one. I'm gonna for the recording. I'm gonna quickly also show it in here. This is where you can get the training plots from the graph. This is where you can actually go and then get the code. Yeah, you can use their code as well. So that's the basically loading the MATLAB file. This is where we have the images. So that's the link directory of the image. So we're going to create the image data store. We're going to have it 80% in the training, image data set for training, 20% for validations. We're going to put the random locations, for instance, for -30 to 30 or scaling. And then we're going to put in augmented images with a size of 227 by 227 and depth of 3. This is your training options. These are each layers that you will have, and this is how they link to each other. You can save it. The next time you just come here, you change, let's say, this one, and then you run. So Is it okay with the coding part of it, right?
Yeah.
Yeah.
I'll do my final project.
I try to record it and we'll see how it works, but definitely make sure you talk with the rest of the student because that's the course.
We'll do this one. Oh,
And the second one generates.
so let's open that up next time.
Yes. And the only thing, make sure each time if it's a different computer, the date set is a different format, right? So change this. If you're running on your computer, change this because it might be different names for you, right?
Should be the same.
If it's the same things, yeah. So
So what if you want to use could we use what do you call it?
Google Maps.
Yeah, want to use Google Net next.
try create one with the Google Maps, generate a code, and that's if it's
So you can't use this code.
no, because the layers are different. That's what architecture is. Right. So, can you please go back to your Data Network Designer? And now we're gonna see like here what you mentioned about how the network will see objects. We're gonna go with the traditional method, report writing, and then we're gonna go with a fun part. Right. So, I'm gonna generate a multi-million pounds technical boards of network, depends on whether you work for Tesla's and these companies. You go to export, that's your network. That's the knowledge you're gonna get from this, right? For Tesla, it's confidential, probably millions of dollars value. That's this one. So click on export train network and results. Click on OK, and once I go to my workspace, that's my network. That's my network information, right? This is the network that you need to save. Save this network, save for the corridor, save your network. So save somewhere actually because you need this. Right click and save it where you can get access to it later on. Bear in mind, this network only works with that data set. That's the knowledge of it. That's the brain of your network, right? So if you're going to use it for numbers, this one doesn't work. That's the sensitive to the pedestrians, cars, and so on. Did you save that?
Yes.
Yeah, save this. I'm gonna save it on my computer as well.
Export. Network. This is my network. Save as. I'm gonna put it as a trained network. Okay.
Great. So, for the report or presentation, you need to defend that your network can classify objects, right? And we haven't tested it yet, right? So, because we don't want to use coding, unless you have to use coding, but because actually the module is tailored in a way that we don't want to use any coding, we're going to use an add-on. It's called UNPIC, UNPIC. Please go to home. Please click on add-ons and search for UNPIC, UNPIC. So UNPIC is basically a MATLAB toolbox that's gonna then help you to visualize what basically your network is seeing. Do I install this? I already have the UNPIC on my computer, so I don't need to do that.
What's it called?
UNPIC, UNPIC.
Yeah.
Did you have it?
Okay.
Yes, fast, please. UNPIC. Yes.
Fast.
Great.
When I do this at home, I go to I go to add-on.
Yes.
It says it's done it, but then it's not in my library.
It's okay, but
And I don't know
if
what-
you know the code of it, you can load it.
Oh,
So each of these, it will tell you how to load. So if you put the functions,
yeah.
they would say that, for instance, what's the function of it.
Yeah. I'm saying,
Yes, it's easy. how you can load it. So asking you to do it manually, and that will load it for you.
Suggested to send later.
No, not again. If it's been downloaded, you just. The only thing is just make sure you have the rest of the required. So this one needs this toolbox. Be sure you have translate. So in your MATLAB workspace, can you please go and type? It's okay, done. Go to your MATLAB. Look. In here, type UNPIC, all capital, and wait to get an error. UNPIC. All capital. Yeah. Enter. So it gives you an error, but the error is telling you, and that's the same for any other toolbox. How you need to use the tool? It says in order to use this tool, you need to unpick your name of network and IMDS. What was the IMDS? Data store, right? Image data store, right? So, do you see image data store in here? No. Did you see image data store in here? No. No, right? In your code, do you see an image data store over there? No. Oh, no. Okay. You have a code for image data store. Go to your code. Because you use that tool, not the code, you don't have these, right? You don't have image data store. You go to the live editor. Make sure you don't click on the run. Run runs the network. Gonna learn again. Just click on run section. Image data store. Add it again. Right. We've done the data augmentation as well. Click on here. Right. Run. So we have both. You have augmentation images and IMDs as well. Click on here. Run section, not run. Run, got to go on there again. Right? Run section 2. Yeah, great. Do the same thing with the data augmentation as well. I will do my computer later. Did you get it? You can take a note of that. Okay? So, let's write the code again. The comments of the code. So it says unpick UNPIC, open bracket, yes. Open bracket, the name of your input, the name of, your network. What was the name of your network? Each of train network. Train network. Sometimes it's number 1, sometimes 2.
No, so you don't know the name.
Yeah. Can type it in here. Unpick, open bracket, the name of your network. Great. Comma, the name of your data store for training. Take note of that as well. So it's a case sensitive. So I'm going to do it in here as well. So I'm going to use the unpick to get an error. And then it's telling me that actually unpick is the name of my network and image data store. This is this one. I don't have an image data store, so I'm going to run these as a run section. I'm going to run also my data augmentation part. And now we're going to write the command unpick the trained network _1, comma, IMDS train, open bracket. Once you do it, can you please enter?
Well, push back to the info.
Yes. It will tell you what's good. So this is a tool that they created for report writing, and we're gonna go and use. And your network is IMDS trained. Great. So the tools that you will see in front of you, it will tell you how many images you have in each class. In the report, we said always you need to have some sample images, right? You remember the code for the numbers, you wrote the code to get it. Each sample. We want more samples. This is best for
random as well.
This is random also, right? Do you need it for?
Why was that black image?
Because then it couldn't process it. So how many did you put? Put 20. Yeah, because it didn't have any. So if you put 19, it doesn't have any. You can use these, but then I prefer the Deep Network Designer distribution and so on. But this is for report writing. Even this tells you how many images that you have and so on, so you don't need to write a code. Okay? You said it was, so change this to 20. This is just for report writing.
These images that has does it include the other images that we added in?
For the data augmentations?
Yeah.
Good question. Yeah. If you want that, instead of IND string, I use AUG IND string. Okay. So, then accuracy. I'm going to see what is my network accuracy. Click on compute network accuracy. It takes some time. And then it's going to give you the network accuracy, which is 97.97%, and in each class. This is really important. What's the network accuracy in each class? Why? Because most probably, if you don't do a network well, if you have image issues, you see 1%, 60%, the rest 90%, your overall accuracy is 80. You keep trying to include your accuracy, but only one class is causing you issue. And that's really common problem in AI. You basically need to go and work with that equation. So for instance, I had the, so this loss and sadness in the facial expressions are quite similar. I found out whenever I went there, actually there was some video from sadness and this loss as well. So the network got confused. So I gave them basically more and better data. Issues that we had. So a coursework 2 years ago on this module was on the truck and ambulances and a car. Lots of the student would keep telling me my accuracy cannot go beyond 70%. So look, I'm going to tell you. I'm assuming ambulance and truck because of the angle of them, your system is classified. Try to actually put some images for angle truck so you can understand the depth of the length of the truck as well. Right? So accuracy per class is 3. The way you define, the way you need to present your network accuracies is not training plot. Training plot is one of them. Always is what we call it a confusion network. And the coursework clearly says you need to present confusion.
Shows the confusion in each class. So it's confused because I have different images of objects.
So we give it a good idea.
This is good. This is good accuracy, but then probably more data tuning here, right? Let's go through and understand because this is one of the questions I will ask you in the presentation.
Does it need to change the organization?
No. All training functions, right? Maybe the minimal zones. So let's read this together. True class is the correct answer. Predict class is an AI detected, right? So the way we read it, the bikes, 93.8% of bikes has been classified correctly as a bikes. 6.2% of the bikes has been misclassified as motorcycles, which I think is valid. Yeah, everybody's saying. 96% of the cars has been classified correctly as the cars. 2% has been misclassified as motorcycles. 1% has been misclassified as pedestrians. What do you think can be the cause of this?
And then people on the motorcycle.
Around the motorcycles. And probably the pedestrian was walking up the car behind the images. What you need to do is go and remove those images if you want. But 1% is acceptable. But if you want, you can actually go and remove those images.
So how does the AI know it's been misclassified? And if it knows that, can it reclassify?
This tool has a solution. You know how it knows the solution? Because you put the images in the class. Right? You call it car, goes back and it goes and check it. But this tool does it, not the AI. This tool.
So can this tool work with the AI and fix that to bring it for 100%?
There's another tool that will study that actually to bring that.
So ideally, what to do, should get some.
Yes. Motorcycles, 97% correct as motorcycles, 1.9% pedestrian, which I think is understandable because in motorcycle we have basically a rider at the top. And 90% of pedestrians classified correctly, but 0.7 on the car, 0.7. So did you understand how you read this, right? So that's something. Then you go to the predict, and I'm going to get a random image from the bikes, let's say. wait for it. Hopefully, we'll pass it. Sometimes it's a struggle. Did he give you the class? It's couldn't find out check something, but actually the RP can fix this.
No, that was no. Was it? That was he was pushing it. Super has pushing the way some car body should be there. It's not really see that. What a location of hearts true. One can continue to do.
Okay, so let's do the prediction explainer. And is the car. I'm gonna go to the graph cap, click on display, and the true class is car, right? Click on data and display. Where do you see the red sign? So it's because random it might be different. Red means sensitive, blue means non-sensitive. Do you think it's correctly find the where it should do?
Minus this is answer that's pretty sensitive.
So it's lost.
Yeah.
Right.
That's complete.
Yeah, but then put it sorry, that's lost.
That's good.
And then no but right. So that means that you're saying your network is accurate, but technique is confused. It's really cheating. So you find out similarities. How can I prove? I will gonna go and then search for an image on Google. And I'm gonna put and then image as hopefully it's a JPEG. I'm call it C1 JPEG download. Okay. Copy everyone. Right. So let's go in here, fix these, and then just remove the quotations. Right. That's a car, but doesn't know. Right. I will display. It's kind of good. But what is funny for that person, I had a project student, it was saying that a motion and a stroke of driver can find out. Red was in here and now the face of driver. That's the lost network, right? So you cannot rely on that. And I don't know why the prediction is indicated. Prediction should give you the accuracy. I don't know why the MATLAB is finding. This happened to me before as well when we load UNPIC. I think once you close the MATLAB, open it up, it will tell you how much you think that's a car amount. The way that the network actually sees, go to the features and click on compute activations. This is how the network sees the car. If you think it makes sense about the agents, that's good then. At least you try to figure out the basically the borderlines or the patterns. Remember the top of the patterns, how is the object to see the lines, right? So, few things in here you can use for the coursework. This image, this number of images, accuracy and confusion metrics, right? Confusion metrics. And predict hopefully works. If it didn't work, then I'm gonna use that as a tool, right? The predict in here. Yeah, this one should really works, but. And basically a graph count of it, and make sure it's correct, and make sure you pick it up correctly, and it should. Right. That's clustering, so you can actually then see the singular data as different segments. So take a note on that one, and then we're gonna go and move on with more activity on that part. So network accuracy in here.
compute network confusions, predict images, network sensitivity, and then I will have the compute activations and so on. So, can you please go to your canvas? And what I want you to do, please, I want you to download the test image, download the test video, download the tutorial 4, which says object detection and classification using YOLO and CNN MATLAB code. So that's the code that I basically created for you. Because I know it is the last part is complex, so I give you the part of the solution so you can start working. And tutorial 4 code. Download the MATLAB code, save it in where you want to operate.
There were 3 variables of this tutorial.
4. 3
You did that one.
Yeah, just it. Yeah. And you test image, test video, and the code, right? Experiment manager will do it after this. Hopefully, I'll have time with experiment.
Just these 2.
And the videos. Did you download the videos and the images? Right. Is it okay with you as well? Is this test video? Great. So I'm gonna go and then use the code. Should we start? Yeah, great. So please go to the MATLAB. But I'll let you to do this. Go to the MATLAB. And what I want you to do, bear in mind, there are a few informations we already have. When you're going to do it at home for the coursework, you should have these. You should have your image data sets, training validation, augmentations, augmentation validations, and your network, right? You need to have these 5 things. If you don't have them, you know how to get it, right? Through the code that we got it earlier. Right. Okay. Now, please go and find out the code that I gave you. Wherever you put it. Please go and find it from here in the MATLAB directory. Yes.
It's this one.
Yes. Yeah. Yes. Great. Can you please go through the code and tell me what's your understanding of it? It is quite important you understand what it's trying to do. Of course, if you don't understand it, you can use large language model to explain to you. Yeah. Which shape here? So that's your code, right? Double click on it.
It should be.
That's what's in it. So that's your CNN. That's the code, right? Okay. So let's go through it together. It's gonna go and load the images that you will have. It's gonna split them in the basically previous training and validation. It's gonna put it in GoogleNet. That's the structure of GoogleNet and so on. You don't need this. If you're already training your network, you already have it. You don't need. You can skip this one. This is in case you're gonna then do another training, right? Clear on this first part? Yeah. Great. We need to use something called YOLO. Have you heard about YOLO? YOLO stands for you only look once. It's an advanced neural network, advanced CNN. For the last couple of years, people that use it, Tesla use it. It's publicly available. Every year, there is one more version of it. The difference between what you will see between a CNN, I'm going to quickly go through so you will basically see the differences. Have a look at it with the data. A car, a single car, a single one. That's the convolutional neural network. Issue, if I have two cars, we cannot identify them. If you have a two bikes, and a bike and a car cannot identify them. Probably says the car is a bike. The video that I gave you, or the images that I gave you, is complex. You see a car, you see a bike there, a CNN cannot do it. You need an advance. But what the YOLO gonna do now for you, it's only gonna tell you there's an object, there's an object, there's an object, there's an object, but I don't know what it is. And your CNN gonna tell them what it is. So that's why we said in here, the YOLO is being used only as an object detection. Doesn't know what it is. It knows there's an object. You can actually train YOLO to also classify objects as well. But this is not what you're gonna do, right? So what I'm gonna do, I'm gonna go through the YOLO and say, just load my YOLO. Just load. And the MATLAB already has a YOLO. Which version of it is a version 4? Right now we have version 10. MATLAB doesn't have it, but if you go to the YOLO website directly, you can download the version 10 of it, which is 5 days. And I'm gonna run the sections. So didn't complain about anything? No, that was the one. Right? Now I'm gonna test my image with your knowledge, with your network. Find the location of the image that you saved, and for you is right click, copy alpha. You go there, put it in here, and try to put a comment as well, change with the text. Right? That's one image. Right? It says run the YOLO detector on it to find out there's an object, and then load my network. In my case, was CNN classifier. What's the name of your network? No, your network. Train network 1, right? Change this to the train network 1, and then make sure you save it in the same folder. Right click on this, and then and call it whatever you want. Do you want to call it CNN classifier like mine or whatever you want?
So just I'm on the set with code.
Yeah.
So I had to load this one.
Yes. Did you load it?
No.
No, you already copy pasted. Just click on that section.
Oh yeah.
Wrong section. Wrong section.
Wrong section. So
No, it's the previous error. That's wrong, right?
and this is
Change it with the location of your folder. And call it whatever you want. If you call it CNN classifier, you don't need to even change the name, but you can call it whatever. Usually I call it net. Which network you do it for the coursework? The best network.
Yeah.
You have a custom CNN, you have a GoogleNet, you have a data optimization one, you do multiple times, the best network, right? So you call it CNN classifier. Oh, let me use the same. So you can coordinate whatever you know. So, this. And this name and this should be matched. If this one is train network 1, this should be train network 1. So load this one and run this against this. So have a look at it here. If your CNN classifier, you save it as a network 1, whatever, this one should be network 1, this one should be network 1, right? If you click on that, it will tell you which one is linked with each other, right? So let's run this. Let's see whether we get any error. So it says that what? It says you don't have a YOLO, right? Click on a YOLO, and you want the YOLO V4 object detector. It says you don't have it. So add on, install, and install. You're bringing in amazing. What was it? I think the latest version of what the MATLAB has is V5 or V4. V4 is more robust than V5. V10 you need to manually. To the error. Did you get the error? Yes, click on. And can you try it? Oh, this one. Add on Explorer. Great. Close it up. Great. Go back to your code, please. And it says you how the YOLO works. So can it go up when you load the YOLO? Yes. Run the YOLO as a run section again. Click the code. Run section. Great. Scroll down and then go to here where you're gonna then test your image. Run section. Only and it goes the extract. Save it. Okay. Close the MATLAB and open it up. Save your network. That's really important. Otherwise, we lose the data. You know. Save your network and then close the MATLAB and open it.
This is, so if I just go on here now and save this, that's
the entire thing. Yes, yeah, I did this. And just be save. Right click on IMDS. Sorry, right click on which one is your network? CNN classifier as well, and make sure you save this file. You save everything, close. Oh, yes, okay. Good. So, inventory. Great. And can you load the CNN classifier, please? Yeah, premium. Great. Go back to the code. You don't need this one. Object detections. Yes. One section. Perfect. Scroll down. One section. You complete close the MATLAB, right? Because we have an issue with the Google Lens as well.
so in addition.